What's up, scholars? We are back, and yes, we are back for more amazing science. And scholars, today I have a confession to make. I've got to tell you, and I think it's time that you know, Mr. W is very, very much in bondage to his coffee. Yes, every morning I need my coffee. I need it to make it through the day. I love the taste of it. My favorite flavor is French vanilla coffee, and it goes down and it's so warm, and then when it gets off in my belly, I want to just do the little dance that y'all do when y'all be, but I can't dance, so I don't. But let me tell you what I really enjoy. I enjoy when my coffee stays warm for hour after hour after hour. And did you know that it's only due to science that we can make that happen? And yes, today we're going to be talking about the science that allows my imitation Yeti to be able to keep my coffee warm all day long. Oh, I love me some science. I hope you love some science too. But don't drink coffee. Drink hot chocolate or something like that because it's better for you. All right. What are we going to be talking about today? We're going to be talking about a science word that involves the movement of heat and electrical energy, okay? What we're going to learn is that there are some materials that allow heat, also called thermal energy, and electrical energy to flow through it very, very easily. And we call that word, drum roll, conductors. Conductors are materials that allow electrical and thermal energy to flow through them easily, and we are going to be looking at the process of conduction. So what is conduction? Conduction is when the energy is moving from one place to another. Remember, this is a hot plate, and my hot plate is a tool that we use to create thermal or heat energy. Thermal and heat are synonymous. That means they mean the same thing. This is a hot plate. My hot plate plugs into the wall with this electrical cord right here. And so it converts electrical energy into thermal energy, and then we use the thermal energy for various applications. The stove in your house might work the exact same way. It's plugged in behind it, and it's going to be converting one kind of energy to another kind of energy. There's always a conversion. Your microwave is another thing that you plug it in and it converts electrical energy into thermal energy. A toaster. I don't even know if we use toasters anymore, but when I grew up, we had these things called toasters, and you would drop the bread off in there and it would make it brown, and then you could stick grape jelly on both sides with some butter, and it was amazing. But toasters converted electrical energy into thermal energy. There are tools that we use in the scientific and real world applications that convert electrical into thermal energy, and our hot plate is one of these tools. Now, remember, we always have to be safe. So I have my safety equipment on, I have my gloves on, and the question we're going to be asking today is, have you ever wondered like how this works, like how the heat moves? Like, how do I take my pot of ramen or ramen, depending on what part of the world you're from, noodles, and I stick them on the pot, and all I do is I twist this knob just like I'm going to do on my hot plate right there, and then a little while later, I've got the most wonderful delicacy in the world, chicken flavored ramen noodles. Like, how does that even happen? Well, let's take a look at it. I've got my beaker, and remember that a beaker is a tool that is used to measure the volume of liquid. So a beaker measures the volume of liquids. When we look at this beaker, it's actually been on the water a little bit. We're going to see that it starts off at 0, then it goes to 100, and it's going to measure in milliliters, and it goes all the way up to 250 milliliters. So if I take my beaker and I stick it on my hot plate, and I turn on the hot plate, I'm telling this hot plate I'm going to increase the amount of thermal energy. I want the thermal energy to go up. I want the temperature to go up. I want the heat to go up. Now, right now there's no thermal energy because it's off. But if I turn this on, now inside this hot plate, it's beginning this process of converting this electrical energy into thermal energy. And it's going to take that thermal energy and it's going to push it up to these burners. The burners are on the top. You might see burners on the top of a stove or something like that at your residence. Now, these burners are going to start to get really hot. Some of you may have seen them where they'll even begin to change color, like they'll glow red or glow orange. That means don't ever touch them. You should never touch them anyway, but definitely when you see the orange and the red, that means don't do it. It's not going to be good for you. It's not going to be good for you. I would not suggest it. So right now, I can literally feel the thermal energy is beginning to rise because heat rises. And these burners are producing thermal energy, and that thermal energy is beginning to rise. But guess what? It's not only coming to my face, it's also rising up into this cup and into this water. And just like we observed whenever we were looking at the changing states and we were boiling the water, we were getting the water to its boiling point, 100 degrees Celsius, where water changes from a liquid into a gas, just like that when we observed. Well, this is the same concept, but now instead of focusing on the water changing states, what we're focusing on is the movement of the thermal energy called conduction. And what we're going to learn is that there are certain materials that conduct heat easily, and there's some of them that don't conduct heat very well, and we call those insulators. All right. Now, when I was growing up, there were two kind of words that we used. There used to be a person that would drive a train. And these are old, because I know y'all's trains are electronic, and they're like bullet trains. They're just like shoo, everywhere, shoo, shoo, shoo. It's just really, really quick. But when I was growing up, style, they had a dude. He would go choo, choo, and the train would go chicka 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 chicka, and he would go choo, choo, and he would go chicka chicka chicka. That person who made the train go was called a conductor. Also, in the music world, if you've ever been to a musical performance, have you ever seen that guy that stands up in the front and he'll have this little stick and he'll start doing this? And he'll be waving his hand. And every time he moves, what happens? The people with the instruments, they begin to play. And he might say louder or quieter and louder and quieter. The conductor, he's called a conductor because a conductor, I want you to remember this, a conductor, think of it as they make things move. They allow things to move. They create this energy, this motion. Conductors allow thermal and electrical energy to flow through them easily. Now, we know a train conductor is not the same conductor as a material conductor, and an orchestra conductor is not the same, but just use that to kind of help you remember the word if you start to forget it. Now, right now, I have definitely have a lot of evidence that the thermal energy has moved up into this water. I can visually see that the water is changing states. I see bubbles all over the place that were not there. There is a mist on that. The thermal energy has moved from the burners into the water because of the process of conduction. Now, we're going to continue to talk about conduction. We're going to look at different materials, and we're going to see what materials conduct thermal energy better, what materials might not conduct thermal energy as good. And we're even going to ask the question, like, what do we even call that? Because there's other words that we're going to study in this concept of conductions. All right, amazing scholars. Y'all are awesome. Hope you had an absolutely wonderful, wonderful, wonderful time. And we'll be back with more amazing science very, 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 very soon.